Hi, welcome to the Master Mathematics Teachers channel. I am Dr. Zhenzhen Miao, currently Assistant Professor at Jiangxi Normal University, China. I have been coordinating and teaching initial teacher education and research courses in mathematics education to both undergraduates and graduates for over 6 years. Before this, I did a master's and PhD at the University of Southampton, UK. Today's presentation is the first in the series of online events on the Master Mathematics Teachers project that I collaboratively work with Professors Christian Bokhove, David Reynolds, and Charalambous Charalambous. You may find our short bios at the MasterMT.org website. The MasterMT project is a tale of 70 master mathematics teachers and their 3,178 students from 5 Chinese provinces: Anhui, Beijing, Jiangsu, Jiangxi, and Tianjin. So, why do we study master mathematics teachers? Expert teachers are better at implementing curriculum and cultivating various teaching learning outcomes than non-expert teachers, as indicated by research conducted in the US. For decades, master mathematics teachers have been playing a leading role in curricular reforms and in their PSPD in China. However, existing studies on master mathematics teachers in China, albeit shedding meaningful light, have been of small scale and mostly qualitative in nature. It is therefore largely unknown at large scale how well master teachers teach and their students learn in various domains of mathematics, and what makes them master teachers in the first place. On the MasterMT project, we set off with 3 grand aims: action, mind, pattern. So first of all, how well do master math teachers teach and their students learn mathematics in the affective, metacognitive, and cognitive domains? How do master math teachers and their students think and know about teaching and learning of mathematics? What are the broad picture of master math teachers and their students? The potential teaching learning mechanisms that explain affective, metacognitive, and cognitive outcomes in mathematics. The general rules via which teachers grow into master teachers. In other words, what makes master teachers? So we designed the project under the guidance of the integrated paradigm, about which we have presented at the 40th International Congress on Mathematics Education back in 2021. At the core of the integrated paradigm are triple traits: multiple measurements, multiple perspectives, the integration of multiple evidence. About the multiple measurements, the integrated paradigm measures the focal issues. For example, mathematics teaching and learning from different angles to see various facets and dimensions of them. In terms of multiple perspectives, the integrated paradigm cherishes research endeavors in deep listening of multiple voices about the focal issues with different roles engaged into the conversation. This allows us and the outsiders to spot the elephant in the room that might be unseen by the insiders, whilst offering insiders opportunities to tell their side of the story behind the scene, and all the beliefs and thinking hidden beneath the visible and therefore more obvious doing. The final stage of the integrated paradigm focuses on systematic integration of multiple strands and layers of evidence at multiple levels. This features the synthesis of results and findings from various methods, weaving together wisdom from quantitative and qualitative approaches, where various methods relate to each other by underlying meanings. Free from artificial superficial paradigmatic barriers. Guided by the IP, we have come up with a dual framework mapping the project at macro and micro levels. At a macro level, we have conducted multiple measurements about teaching, learning, and the connections between teaching and learning. We have observed the lessons and analyzed them with 3 existing observation systems. The opportunity to learn, developed by Reynolds et al. 2002. The International System for Teacher Observation and Feedback, developed by Tedley et al. 2006, and also reported in the recent article by Miao and Reynolds 2018. The mathematical quality of instruction, developed by Hill and Ball in 2004, and also reported in the article Learning Mathematics for Teaching Project in 2011. Learning is in affective, cognitive, and metacognitive spheres, was measured with latent constructs and a mathematics test. About the teaching and learning mechanisms, we have hypothesized and tested multi-level and multi-level structural equation models. On the other hand, to collect multiple views from different roles, we have conducted post-lesson interviews with the teachers. We asked the teachers to fill in a questionnaire collecting their teaching beliefs, knowledge, and self-efficacy, alongside other background information. We have taken part in teaching research events and listened to teachers' colleagues' views regarding a lesson they just demonstrated. We as researchers have interpreted their teaching in unstructured ways. As researchers, we have also seen patterns of a master teacher's teaching and work longitudinally over a period of 40 school days. The final touch of the framework lays on interweaving multiple strands of evidence together to represent and explain the holistic reality of masterly teaching. The ultimate integration of evidence sees multiple statistical analyses, such as multi-level modeling and multi-level structural equation modeling, joining the in-depth analysis of qualitative data, such as a case study of master teachers' work over 40 school days, and participatory observations of teaching research meetings at the school, municipal, provincial, and national levels. So, at the micro level, in terms of action, through structured and unstructured observations of lessons, we aim to understand the way teachers teach and students learn, what they say to each other in the lessons, their cognition and metacognition in action as it happens in the class. Also through observation, interview, and survey, we aim to evaluate both teachers' and students' status of knowledge, their beliefs, their knowledge, and regulation of their own thinking. In other words, metacognition. Through teacher reflection, our observation and survey, we aim to understand the patterns of teacher PD trajectories, PD in action, the patterns of masterly teaching across classrooms, the patterns of 3 learning outcomes, and how the student background interplays with teaching and these outcomes. We plan to follow a master teacher for 1 month. In the end, we have made it to 40 school days. This allows us to see a world in a grain of sand and the masterly teaching in the case study. Pulling all the results and findings together, we hope to have a deeper understanding of the masterly teaching reality by seeing pupils and teachers in schools and the system. So that's a brief introduction to the MasterMT project's aims and design. Thank you so much for joining us in today's presentation. We'll be talking about the project's results and findings in our future events. Stay tuned and see you soon.